Some of you should start studying now. And again, if you're doing the extra credit, that is something that's going to help you in preparing. All right, you don't have this in your notes. We'll get to your part in a moment. I just want to get you to think here as we start the aspect of volume. So this is volume of a cone and volume of a pyramid. Now, in my other school, I used to have a set of shapes, and I would have a cylinder. It was clear plastic, and it had a hole in the top. The rest was solid, and I had a cone the exact same size. The circumference of the cylinder and the circumference of the cone were exactly the same size. The height of the cylinder and the height of the cone were exactly the same size. And what I would do is I would fill up the cone with water, and I'd have the cylinder that goes with it, and say, how much would it fill up the cylinder of the same size? So, for example, if you look at this, if I had this thing filled up with water, because it's basically the same size as that cylinder, and I brought it over, not the water, everything. All right, the water's going to stay there. Go with it, water. All right, now when I rotate it, the water's not going to rotate. Come on, water. All right, and I poured that water from that cone into that cylinder. How much would it fill up that cylinder? I would also do the exact same thing with a pyramid, because I had a prism, and the base of the prism and the base of the pyramid were exactly the same size. And the height of the prism and the height of the pyramid were exactly the same size. And so I'd have the pyramid filled up with water and said, if I pour in the water from the pyramid into the prism with the exact same area of the base and the exact same height, how much would it fill it up? So that's the situation. Whether it's a cone or a pyramid, a cone filling up the corresponding cylinder, same area of the base, same height, both for the cylinder and the cone. Pyramid, same thing, same area of the base, same height. How much is it going to fill up either the cylinder or the pyramid? Any thoughts? How much would it fill it up? Nick? Halfway? Okay. A lot of people say half. How much would it fill it up? Jack? How much will the cone fill up the cylinder? How much will the pyramid fill up the prism? And they're the same amount, by the way. It's the same fraction. Hopefully you agree it wouldn't completely fill it up, right? Because if you look at the volume, I mean, look at the pyramid. Let me bring it over. You see how it has less space to take up stuff, right, than the prism? And the cone is exactly the same way. So you know it's less. It's not going to be 100%. So how much does it fill it up? Kaylin? 3/4, okay? 3/4 full? Who else has a thought? How much is it going to fill it up? How much? Ashton? 1/4. All right, so only a fourth. Right, so when you look at how much I'd fill up the pyramid and how much I'd fill up that prism, 1/4. All right? What else? Who else has a thought? Jack? Huh? Half? Okay. Who else? How much is going to fill it up? Come on, get in the game. Raquel? 1/5? Okay. Well, which one? I heard I'll go with, and I didn't hear anything after that. Why are you in such agony? It's just a guess. All right, she'll go with 1/3. John? 2/4? So half. That would be a half. All right. What else? Who's got a thought here? How much is going to fill it up? Connor? 3/7. All right, Connor always likes to be a little bit off the beaten path, but that's okay. Byron, 5/8. 5/8. So over half, right, on that one. What else? Any other thoughts? Let's go this way. Let's take a vote. How many think it would fill it up over half? Let me see your hands. All right, put your hands down, then how many under half would be the rest of you, right? Under half. You can't be nothing. You're either over a half or under a half. All right, hold on a second. I'm going to ask you one more time. Choose one. You can't say nothing. All right, you're either going to say, I think it'll fill it over a half, or I think it'll fill it under half. How many think over a half? Okay, put your hands down, then how many think under a half? I want to see who was left. Okay. The answer actually is under a half. And if you look at the pyramid there, there's a lot of space all up in here, right? And it goes all the way around it. Again, when I had the shapes, I could show it to you, spinning it and everything, and letting you see. And it's really no different with the cone. You got all this space around here, right? All the way around that cone up the whole height. So there's quite a lot of space. Well, the answer was said. And so in your notes here, you guys have this in your notes, and the answer really is 1/3. The volume of a pyramid and the volume of a cone is 1/3 the area of the base times the height. And again, when I had the water, I would pour the cone water into the cylinder, and it would fill it up about 1/3. And you could see it clearly. It looked like about 1/3. And I did the same thing with the pyramid, and it filled up about 1/3. And it's exactly mathematically 1/3. It's just the way it is, mathematical formula. So if you can figure out the area of a prism, you can figure out the area of a pyramid if you'll just take 1/3 of what we did. Same with a cone, 1/3. 1/3 area of the base times the height. And again, we're going to look at what kind of pyramid it is. What's the shape of the base? Will determine the formula for area of the base. A cone always has a circle for the base, so that's always pi r squared. Okay? And away we go in figuring out the volume of a pyramid or the volume of a cone. So let's do a couple problems. Here's a pyramid. And we need to figure out its volume. And like always, we're going to start with the formula. I usually just go PYR for pyramid. Be careful, that 1/3, don't forget it, 1/3. And what is our shape? Somebody raise their hand and tell me what kind of shape, John? Triangle. No, not the base. What kind of shape is the base? Why? It is a rectangle. Yeah, the base on this is right down here, right? The sides are triangles, John, but the base is a rectangle. And then times the height. Oh, and by the way, let me go back and make sure you guys are clear on what the height is for a pyramid or for a cone. Sometimes they'll show you the value right inside, like they did here. It's always the perpendicular distance, by the way. But look, that could be anywhere, right? As long as it's the distance from the height perpendicular to the peak, right? Doesn't matter where it sits. Here they show it going from the center of the pyramid right up to the peak. Same thing with the cone. They're from the center, oops, I moved the whole thing. From the center of the cone right up to the peak, okay? That is the height. So be careful. Is the height this distance along this edge? No, that's not the height of a cone. Perpendicular, and that's not perpendicular. Is the height of a pyramid along one of the edges? No, that's not perpendicular from the base to the vertex, the peak. And look, haven't all the heights been perpendicular? And they're not going to be any different now because math is orderly, not like English. Gotta throw that in when I can. All right, so that's it. Go ahead and try it. See if you can get the volume of that pyramid. Go ahead and finish it off. All right, you above 50 or below 50? 100, 150, 175. All right, and that is the ballpark, right? And again, this one was nice because they didn't give you any extra numbers. 160 cubic inches, right? 160 cubic inches is what you should have gotten. If they give you extra numbers, you got to disregard them. Just don't worry about it. Know what numbers you need. What numbers did I need for the area of my base? I needed the 10 and the 8. What was the height of my pyramid? 6 inches. Don't forget the third. Don't forget the third. Hey, if it comes to a point, it's a third for the volume. Third area of the base times the height. Let's look at the next one. All right, so this one, volume of a cone. I want you guys to follow me on this. I reminded you guys of this when we did volume of a prism and a cylinder. I want to remind you again. Sometimes the formula will look like this, and I want you to do it right now. Sometimes they'll put a capital B. Oh, and I forgot my third, right? Stick the 1/3 in there. Come on, give me my red. 1/3 capital B times H. Again, in this notation, what do they mean by capital B? They mean area of the base. Just want you to be aware of that because sometimes they'll provide a formula for you on a Stanford Achievement Test or on a PSAT test or maybe even the ACT SAT test. And you got to know that that capital B means area of the base. I like better the capital A with the subscript base, but you know, it is what it is. Okay, so our volume, the third is a third. And what formula, Blake, do I put for area of the base? Pi r squared, I agree. And times our height. All right, so I did an extra step on that one just to make sure you guys remembered about the capital B. All right, see if you can finish it off. Finish it off. More than 750 or less than 750? More than 1,000 or less than 1,000? More than 1,250 or less than 1,250? All right, you are in the ballpark. Which ballpark is the question? Orioles or the Nats? Any Oriole fans in here? I'm an Oriole fan. Any Nats fans in here? I'm a Nats fan. All right, I'm both, I hate to say, but anyhow, 1,004.8. That looks like a comma there. That's a point. How many got that correct? All right, good. These really aren't hard as long as you know how to use the formula and you remember that something with a point is a thoid. All right, don't forget the third. Don't forget the third. Don't forget the third. Don't forget third. Any questions on those two? All right, here's what's going to happen, though, in quiz and test. We're going to stick a number, you know, like maybe I'll stick a 20 meters there. All right, be careful. You got to know that. Or what if instead the dotted line went all the way across, there was no 8 there, and it said 16M right there? Well, be careful. You got to use the radius, not the diameter, right? And if they really want to make it hard, what if they gave you the circumference of the circle instead of the radius? You'd have to use the circumference formula, right, to get the radius? We better review those. Somebody raise your hand and tell me one of the circumference formulas. One of the circumference formulas. Gabe? 2 pi r is one of them. What's the other? Byron? Pi d. So don't forget those because sometimes it's the only thing that we could do really to make these a little bit more interesting is have you deal with a radius or diameter or circumference. Okay, last thing, last formula, volume of a sphere. By the way, the Earth is a sphere. Right? It is. It's a big ball floating in the middle of space. What keeps it going around the sun? Gravity, right? Gravity, gravity, gravity. Same thing that keeps the moon going around the Earth. And that's a good thing. All right, so let's find the volume of this sphere. Well, we need a formula. We need a formula. Well, how do you come up with this? I don't know. But it's not 1/3. That would be a pyramid or a cylinder. But it does have a 3 on the bottom. So what goes up top? John? No. Actually, if you think back, way back to the surface, did we ever do the surface area formula of a sphere? Okay. So you guys don't know that one, and that's okay. I think we worked it. That was one of the 3 days. We did do it. If you can remember, it was something pi r squared, surface area of a sphere. Anybody remember that formula? We did it one of those days when we didn't have homework. All right, now you make me find it. Might be the day we didn't think it's this day. See, we were doing surface areas there. There it is. See, I knew we had it, right? So you see the formula for surface area of a sphere? It was 4 pi r squared. And math is nice and orderly. So what goes on the top? 4. Now, there's one more thing to finish the formula. We're doing volume. So it's 4 pi r cubed. Remember, cubic units. The pi r cubed. All right, I don't know what that red dot is. It's extraneous. Is it in your notes too? All right. It just popped up out of nowhere. So extraneous dot. Well, you know, first edition. Where was the red triangle? Just a real, oh, right there. Oh, well, who knows? Just something to keep you awake. Not really. Wasn't planned. All right. So, again, all we got to do is be able to run the formula, and there's really only one thing to input. So this sphere, it gives us a radius. So let's go ahead and figure out the volume of this sphere. I usually do SPH, and I'm going to write the formula one more time, because every time you write it helps you remember. But look, a 4/3 is a 4/3. A pi is a 3.14. And the radius is 4 units, right? All right, you should have a cube button on your calculator. If you do not, everybody look up at the screen. If you don't have a cube button, you either have an X to the Y button, a Y to the X button, or a caret button. All of those allow you to do an exponent. So if you're going to use this button, you would punch in the base, the 4, hit that button, and then punch in the 3, the exponent. Or you can do 4 times 4 times 4. But it's good to figure out your buttons on your calculator. All right, figure it out. Go ahead and multiply that out. See what you get. And again, you're going to treat that 3 on the bottom just like the 1/3 from the other ones, right? Just divide all the top by 3. And that 4 is on the top. This one we're definitely rounding off. All you're doing is punching buttons. Punch, brothers, punch with care. Question? Yeah, but remember, order of operations. Do the 4 cubed first. Then usually what I do is multiply it times the 3.14, multiply it times the 4, and then divide by the 3. It's the easiest way to do it. Say your answer if you got it. 267.9 units cubed would be your answer. again, guys, do order of operations, do your exponents first. Everything in the top is times itself. So the 4 is the top of a fraction. The 3.14 is really the top, right? The bottom of it's a 1. So you multiply all the tops, and then you divide by what's in the bottom. Divide it by 3. And you'll get the 267.9. Questions on that? Jack? Why? What do we usually... All right, let's look at the next example here. All right, in this example, we want the volume. We know the formula, volume of a sphere, 4/3 pi r cubed. All right, grand finale of chapter 13. Besides review questions on Thursday, see if you can find the volume of that sphere. I'm going to pause the video, so start it back up when you're ready. More than 30 or less than 30? More or less? More than 40 or less than 40? I have less. 33.5 meters cubed is the volume of that sphere. How to use the circumference formula to figure out the radius, because you gotta know the radius. Circumference equals 2 pi r. I first found the red radius of 2. Now that I have the radius, I can put it in my formula, and I can figure out the volume of that sphere. How many got that right? Okay, good job. It's a good job. Too bad more of you didn't. Questions on that? Questions? Raquel? Okay, and what's confusing you? Speak up, because I'm not hearing a sentence yet. 12.56 divided by 2 times 3.14. And again, you can make that a whole number first if that makes you feel any better. That's a 6.28. 12.56 divided by 6.28 is 2. If you leave the 2, divide the 12.56 by 2, then divide it again by the 3.14, or use a parentheses. You just have to know how to use your calculator. Radius is 2. Other questions? Anybody else? Yes, Kirsten? Again, the way to, if you want to look at it as fractions, this is in the top, order of operations, do it first, times this is in the top, times this is in the top, this is in the bottom, so divide it by the thing in the bottom. That's how you do fractions. All right, you got your homework? Quiz tomorrow, quiz tomorrow, quiz tomorrow.